We are told electric vehicles, known as EVs, are the key to a sustainable future. But ask yourself, are they really? While they are hailed as the solution to climate change, there's a hidden side to the EV revolution that's not being talked about enough. This video dives deep into the environmental cost of electric vehicles, the parts of the story that are often overlooked. Let's explore what the real cost of driving an EV might be, from battery mining to disposal and everything in between. Let's look at the timeline of the EV revolution. In 1997, Toyota made a major leap for sustainable transport with the launch of Toyota Prius, the world's first mass-produced hybrid car. The Prius combined a petrol engine and an electrical motor, offering better fuel efficiency and reducing emissions. However, Toyota was cautious about going fully electric. Despite the growing push for zero-emission cars, Toyota refused to sign a global agreement to phase out fossil fuel cars by 2040. Rather than focusing entirely on electric power, Toyota invested heavily in hydrogen technology. In 2014, Toyota launched the Mirai, a hydrogen fuel cell vehicle that runs on hydrogen and emits only water vapors as exhaust. Hydrogen fuel cells offer several benefits like zero emission. Quick refueling takes around 5 minutes, much faster than electric vehicle charging, probably sometimes overnight. Larger driving range compared to some EVs. However, hydrogen fuel cells also have their own challenges. Hydrogen production is energy intensive and often relies on natural gas, which can offset their green benefits. There is a lack of refueling infrastructure globally. It is costly to produce and store hydrogen safely. While hydrogen has promise, it still needs more development to become a mainstream solution. So, what are the environmental costs of EVs? The number one, there is a hidden cost to battery mining. Yes, electric vehicles rely on batteries, specifically lithium, cobalt, and nickel. These materials are essential to power the EV revolution, but mining them comes with a significant environmental and human costs. Once again, lithium mining in places like Chile, Atacama Desert depletes water supplies, affecting local ecosystems. Cobalt mining, primarily in the Democratic Republic of Congo (DRC), has been linked to child labor, forced labor, and unsafe working conditions. In some cases, children as young as 7 years old are forced to work in artisanal mines using rudimentary tools to extract cobalt from unregulated mines, often in life-threatening environments. This is really sad. These conditions lead to severe injuries, exposure to toxic substances, and sometimes even death. The demand for cobalt and other materials essential to EV batteries has led to exploitation of vulnerable populations, contributing to an even more complex ethical dilemma. As mining operations grow to meet the demand of the electric cars, the social and human rights issues involved continue to worsen. The process of extracting these materials also leads to deforestation, soil erosion, and contamination of local water resources, impacting the entire communities and ecosystem. While recycling efforts for EV batteries are underway, they are far more efficient, meaning many batteries still end up in landfills, compounding the environmental and human cost. I'm not just giving this information by myself. The source of this information is earth.org, and there's a link in the description, and it is very valid. Number two, the power grid and the energy sources. Are EVs really clean? These batteries require electricity to charge. So think once again, are these EVs really clean? When you plug in your EV, you might assume that it's running on clean energy. But if you're charging your EV using electricity from coal powered plants or natural gas, you are still contributing to the carbon emission. For example, in countries like Australia and parts of the United States, coal remains a major source of electricity. In China, where many EVs are manufactured, coal is still responsible for over 60% of the electricity generation. This means that the full life cycle emission of an EV depend heavily on your local energy grid. The more renewable energy your region produces, the cleaner your EV becomes. The source of this information is CarbonBrief, and there's a link in the description. Please go and have a read. The number 3, EV battery recycling. Now, there is a missing link here. So you have charged your EV, driven it, and now it's time to deal with the battery. But what happens when your EV battery reaches to the end of its life? Unfortunately, the recycling process is far from efficient. Only 5% of the world's EV batteries are being recycled at the scale today. The rest end up in landfills. Toxic chemicals from the battery can contaminate soil and groundwater. There are huge fires in the landfills due to the high energy content in discharged batteries. Recycling technologies are improving, but for now, we are facing a huge environmental challenge when it comes to disposal of the millions of EV batteries in the future. Now, source of this information is GreenBiz, and the link is there in the description. Please read it. So there is clearly a need for greener mining practices. It's not all bad news. We need to innovate and improve the current EV model. Greener mining practices could make a massive difference. For example, bioleaching or electrokinetic remediation technologies could help extract metals without damaging ecosystems. Solar-powered mining could reduce the carbon footprint of extraction. Furthermore, battery recycling needs to become more efficient to lower the demand of new materials. Clean energy grids and infrastructure. Also, there is a need for clean energy grids and infrastructure. EVs won't be fully green until we can charge them using renewable energy. It's essential to transition to clean energy such as solar and wind on the global scale. Governments must also increase investment in EV charging infrastructure and recycling facilities to make EVs more sustainable. So what does this mean for the future? The truth is, EVs are not a silver bullet. They are a step in the right direction, but the full environmental impact needs to be examined. What's needed is sustainable mining practices, renewable energy grids for clean charging, efficient battery recycling, more innovation in alternative fuels like hydrogen. EVs alone won't save the planet, but they can play a key role if we fix the underlying issues. So here's my conclusion. EVs are part of the future, but they come with their own set of challenges that needs to be addressed. From mining to charging to battery disposal, there are environmental costs that we can't ignore. As consumers, we need to push for better solutions, and as a society, we need to ensure that the sustainability is a top priority across the entire life cycle of EVs. So now it's time for a balanced conversation about the true environmental costs of electric vehicles. Let's not just look at the tailpipe emissions, but the entire journey. Thank you for watching, and if you believe in transparency and want to see more videos like this, don't forget to like, subscribe and hit the bell for updates.